Welcome to FUNNYMATH page. In today's lesson, we are going to talk about using prime factorization to find the lowest common multiple and also the highest common factor of given numbers. But we're going to begin with lowest common multiple, which we normally say the LCM or the least common multiple. So let's begin. We have 12 and 20. So how do we find the lowest common multiple of these two numbers? That's a simple approach. You know that we can use the listing method to find the lowest common multiple of these two numbers. That is, you have to find the multiples of 12 and also the multiples of 20, then we get the answer. But in this case, you're going to use the prime factorization method to get the answer, or the LCM, which is also called the least common multiple. So let's begin. So I can decide to use the factor tree diagram to find the prime factors of 12 and that of 20, or I can use the table form. So I'm going to use the table form here. So just have to get the table like this. So here is going to be 12. That of this is going to be 20. You see, I've left this place. That's why we're going to write the prime numbers. You should know that this portion, this column, is going to be for prime numbers only. You don't have to write a composite number here. Just ask yourself, which prime number should you write it here in such a way that it can go into either 12 or 20, or it can go into the two of them at the same time. So I can use, let's say, 2. So 2 is a prime number and it can go into 12. It can also go into 20. So 2 goes into 12 6 times, goes into 20, we have 10. So that is it. Now let's do something. We still have to break this 6 and 10 down. So I have to continue from this end. So that's going to be this. We are doing that in such a way that our last numbers are going to be 1 1. So we still have to break it down. Now the numbers are 6 and 10. Which number are you going to use to break 6 and 10 down? So I can think of 2 once again. So 2 goes into 6 3 times, goes into 10 5. So that is it. Let's move on to the next one. Now we have to break 3 and 5 down. Which number am I going to use here? Remember, I have to use a prime number. So considering 3 and 5, I think the prime number that we can use here is going to be 3. Now 3 goes into 3 1. 3 goes into 5. That's not possible. So you just have to write the same 5. Now you can still continue. You have to break this 5 2 down. So that means obviously here is going to be 5. So 5 goes into 1. It's not possible. So write the same 1. 5 goes into 5. That's going to be 1. So we are done. Because we can see that the numbers are now 1 1. That means we are done. So how do we get the LCM? The LCM is just the product of the prime number that we have here. So simply, therefore, our LCM, which is the lowest common multiple, is equal to 2 times 2 times 3 times 5. So let's multiply. 2 times 3, that's going to be 6. And 2 times 5, that's going to be 10. And 6 times 10 is going to be 60. So the LCM for 12 and 20, that's going to be what? 60. Now let's move on to the next one. 4, 6, and that of 10. So how do we do that? The same approach. We are going to draw our our table here. So this time we have we have 3 numbers. 4, 6, and that of 10. So let's begin. So which prime number are we going to write here? We can think of 2. That's obvious. 2 goes into 4 2 times. 2 goes into 6 3 times. 2 goes into 10 5 times. So we can still simplify. So now the prime number that we have, the number that we have are 2, 3, and 5. So they are prime numbers. So I have to take them one after the other. So I have to change this 1 to 1. So that means I have to use 2. 2 goes into 2 one time. 2 goes into 3. That's not possible. So write the same thing. But remember that when the number is not able to go into that number, into this, just write the same number. So 2 goes into 5. It's not possible. So write the same 5. Now we move on. So that means we have been able to, break this 4 down to 1. So you can think of 3. So 3 goes into 1, not possible. Write the same 1. 3 goes into 3 one time. And 3 goes into 5. That's not possible. So write the same 5. Now let's move on to the last one. That's going to be 5. So you just have to use 5 here. So 5 goes into 1, 1, goes into 1, 1, and 5 goes into 5 one time. So we are done. Now we have to find the LCM. So therefore, the LCM, that's going to be the product of these numbers here. So we have 2 times 2 times 3 times 5. We have 2 times 2 times 3 times 5. So let me multiply. 2 times 3, that's going to be 6. And 2 times 5, that's going to be 10. So we are still getting 60 like we got in this one. Now, Sometimes you can leave your answer as this, 2 times 2 times 3 times 5. I mean, it can be written as, 2 exponent 2 and 3 times 5. This is also the LCM. If you want to leave your answer, in index form or in exponent form, that is allowed. You can also write it in the normal form or in the standard form, that is 60. So let's move on to the next question. So let's find the LCM of the numbers 16, 30, and 36. So let's begin. So I have to get my table. So this is my table. So we have, 16. So this is 30. And we have 36. So always you have to leave a column, for the prime numbers. So now let's begin with, the breakdown. We have 16, 30, and 36. I mean, which number are we going to use here? Which prime number? So let me think of, 2. So now 2 goes into 16. That's going to be 8. Goes into 30. We have 15. 2 goes into, 36. So that's going to be, 18. That is it. Now we have 8, 15, and 18. You can think of, 2 once again. 2 goes into 8 4 times. It goes into 15. That's not possible. So we have the same 15. 2 goes into 18. So that's going to be 9. So we are done with that one too. You can still simplify. We have 4, 15, and 9. So let's think of, 3. So 3 goes into 4. That's not possible. So write the same, 4. I mean, let me get that one well. 3 goes into 15 5 times. 3 goes into 9, 3. Can still simplify this one. Now let me think of, 2. 2 goes into 4 2 times. 2 goes into 5. That's not possible. Write the same 5. 2 goes into 3. Write the same 3. You have to still simplify. I mean, I have to, extend the lines. We have 2, 5, and, 3. So I have to take, 2 to break this 2 down to 1. Goes into 5, the same 5. It goes into 3, the same 3. So I can still simplify this one. Now we have to break this 5 down. Let me take 5. Goes into 1, 1. Goes into 5, 1. And then goes into 3, the same 3. So that means the last one is going to be 3. So we take 3. Goes into 1, 1, 1. Goes into 3, 1. So we are done. So now we can get the LCM for these 3 numbers. And I mean, the whole lot of stuff, we have to multiply all these to get the LCM. So therefore, the lowest common multiple is equal to, 2 times 2 times, 3 times 2 times 2 times 5 times 3. So like I said initially, you can leave your answer as, let's simplify this one. So that's going to be 2 exponent. We have how many 2's here? 1, 2, 3, 4. 2 exponent 4 times, 3. We have how many 3's? We have 2. 3 exponent 2 times 5. So that is, another way of writing the answer. But if you want to write it, in a standard form too, that is also allowed. So let's multiply. So before we do the multiplication, you see, 2 times 5, that's going to be 10. So that will make the multiplication, easier. So let's multiply. 2 times 2 is 4. 4 times 3 is 12. And 12 times 2 is going to be, 24. 24 times 3, that's going to be 72. So you have 72 times 10, which is 720. So that means the LCM is 720. That's a big number, but that's the lowest common multiple for 16, 30, and 36. Let's find the LCM of, the numbers 18, 42, and that of, 90. So let's begin. Let me get my table. So here's, 18, 42, and that of, 90. The prime number that we're going to use in this case, let's take, 3. So 3 goes into 18, that's going to be 6. Goes into 42, that's going to be 14. We have 14 here. And 3 goes into 90, 30. So let's break the next, set of numbers down. Let's use, 2. So we have 2 here. 2 goes into 6. 3 times. It goes into 14, 7. It goes into 30. That's going to be 15. We have to still break the next set of numbers down. Now we have 3, 7, 15. You see, 3 is a prime number, so let me use prime. 3 here. 3 goes into 3, 1. Goes into 7. That's not possible. Write the same 7. Goes into 15, 5. I can still break it down. So let's take 7. 7 is a prime number. So we have 7 here. Goes into 1, 1. Goes into 7, 1. Goes into 5. It's not possible to write this in 5. So the last number is going to be 5. So that we can break it down to 1, 1. So we have 5 here. So 1, 1 goes into 5, one time. So that is it. Let's find the LCM. So the LCM for 18, 42, 90. The LCM is equal to 3 times 2 times 3 times 7 times 5. So let's multiply. So we have 2 times 5 there. So 2 times 5, that's going to be 10. 3 times 7, we have 21. 21 times 3, that's going to be 63. So you're going to get 63 times 10, and that will give me 630. So that is the LCM for 18, 42, and 90. Let's get the last one for the LCM. So let's find the LCM for 9, 18, and that of 16. So let me get my table. So we have 9, 18, 16. So which prime number are we going to use? Let's use 3 here. And 3 goes into 9. 3 times, it goes into 18, 6. 3 cannot go into 16. So write the same, 16. So let's move on. Can still break 3, 6, and 16 down. So let me take 3 once again. 3 goes into 3 one time. It goes into 6 2 times. 3 goes into 16. That's not possible. Write the same 16. So now we can break 2 and 16 down as well. So let me use 2. So we have 2 here. 2 goes into 1. That's not possible. Write the same 1. Goes into 2 one time. Goes into 16. That's going to be 8. You still have to break 8 down. So let me use 2 once again. 2 goes here, 1 goes here, 1 goes into 4. 8. I've even said it. 4. So let's take another 2 once again. This is giving us a whole lot of work. We have 2, 1, 1, and another 2 once again. So the last one is going to be this 2 once again. We have 2, 1, 1, and 2 goes into 2 one time. So that is how we can find the LCM. So let's get the LCM. The lowest common multiple is equal to 3 times 3 times 2 times 2 times another 2 and times another 2. So the 2's are 4 and the 3's are 2. So we can simply write the answer as 3 exponent 2 times 2 exponent 4. That is correct. But if I want to multiply to get the actual number, we can also do that. So 3 times 3, that's going to be 9. Now 2 times 2, that's going to be 4. 2 times 2, another 4. 4 times 4, that's going to be 16. So you have 9 times 16. And let's multiply 9 by 16. That's going to be 144. So that's the LCM for 9, 18, and 16. Now let's turn attention to the highest common factor or the greatest common factor. Remember, we are talking about highest common factor now, or the greatest common factor. They are all the same. We are finding the highest common factor of 15 and 21. So you have 15, 21. So let me get my table the same way. We have 15 and 21. So which prime number we're going to use here? Obviously, that's going to be 3. And 3 goes into 15 5 times. Goes into 21 7 times. Now before you move on, let me tell you something. You see that this 3 was able to go into both 15 and 21. So let me take this one. Let me highlight this one. That means I'm going to take it for something. Let's finish and you understand what I'm talking about. So the moment you see that the prime number was able to go to the two numbers or into the numbers here, just highlight it. Put it down. We're going to use it to do something. Now let's move on. We have 5 and 7. So we can use 5 here. 5 goes into 5, 1. 5 goes into 7. That's not possible. We write the same 7. So we are not going to take this 5 because 5 was not able to go into 7. Now we come to 7. We can take 7 here. 1. 7 cannot go into 1, so we just write the same 1. And 7 goes into 7 one time. So we have seen that 7 2 was not able to go into the whole of the numbers here. So now the highest common factor is going to be the number that I highlighted here. That's going to be 3. Just a single number. So that's the highest common factor or the greatest common factor. That is it. Let's move on to the next one. So let's find the highest common factor of 24, 32, and that of 64. So we have 24 here. We have 32, and that of 64. So which prime number? Let's think of 2. And 2 goes into 24. That's going to be 12. 2 goes into 32. that's going to be 16, and goes into 64, 32. So that means this 2 is able to go into the 3 numbers here. So I have to take this 2. I have to highlight it. Let's move on to the next one. We have, 12, 16, 32. I can still think of, 2 once again. And 2 goes into 12, 6 times. It goes into 16. 8 goes into 32. That's going to be 16. So this 2 is also able to go into the 3 numbers here. So I have to highlight this one too once again. Let me get my 16 well. Now another one, we have 6, 8, and 16. I can still think of 2 once again. 2 goes into 6, 3 times. It goes into 8, 4 times. And it also goes into 16. 8. It is able to go into the 3 numbers once again here. So I have to take these 2 once again. So now, let's come to, 3, 4, and 8. So I can take 3, and 3 goes into 3, 1. So not be able to go into 4, so I have to write the same 4. And 3 goes into 8. That's going to be the same 8. So I'm not going to take the 3 because it's not able to go to 4 and 8. So let's come to, 2. Now 2 goes into 1. It's not possible. Take 1. Goes into 4, 2. It goes into, 8. 4. In fact, we are actually done. We can, use this information to get the highest common factor. But I just want to, simplify to the lowest, to 1, 1. That's why I'm still doing it. But at the moment, the highest common factor is, quite here. That is clear. So let's move on. We take 2 goes into 1. That's not possible. Write the same 1. Goes into 2 1 time. Goes into 4, 2 times. So finally, I'm going to take, 2 to complete it. So you have 2 here. 2 goes into 1. That's not possible. Write the same 1. Write the same 1 here once again. 2 goes into 2, 1. So from this point up to this point, none of the prime numbers were able to go into the, into their respective, numbers here. That's why we didn't select them. So now, how do we get the highest common factor? The highest common factor is equal to the product of the numbers that, we selected here. So that's going to be 2 times 2 times 2. We have 2 times 2 times 2. So that's going to be 2 exponent 3, which is obviously going to be, 8. So that's the highest common factor of 24, 32, and 64. Now, remember that for LCM, we multiply all the prime numbers here. But for the highest common factor, we select, the prime numbers that were able to go into their respective numbers. That is what you have to know. Let's take the next question. So the numbers are 18, 36, and that of 60. So the prime number that I'm going to use here, let me use 2. 2 goes into 18, 9 goes into 36, 18, and it goes into 60, you have 30 here. So this 2 has been able to go into the 3 numbers here. So I have to select it. Now let's move on to the next one. Let me take 3. So 3 goes into 9 3 times. It goes into 18, 6. It goes into 30, 10. So I have to take this 3 too, because it is able to go into the 3 numbers here. Let's move on. So now we have 3, 6, and 10. Let me take 3. 18, 36, and that of 60. Goes into 3 1 time. It goes into 6 2 times. But it will not be able to go into 10. So you have to write the same 10. And that means I have not taken this 3. Let's take 2. We have 2 here. 2 goes into 1. It's not possible. Write the same 1. Goes into 2. 1. It goes into 10 5 times. So finally, I have to take 5 to complete it. So you have 5 here. Goes into 1, not possible. This one too. And 5 goes into 5 1 time. So obviously, the highest common factor is equal to the product of 2 and 3. So that's going to be 2 times 3. And that is 6. So that is the highest common factor of 18, 36, and 60. Let's take another one. So let's find the highest common factor of 20, 12, and 28. 20 here, 12, and we have 28 here. So the prime number, that's obviously going to be 2, and 2 goes into 20, we have 10, goes into 12, 6, goes into this, 14. So 2 is able to go into the 3 numbers, we have to highlight it. Let me come to the next one. So you have 10, 6, and 14. I can still think of 2. 2 goes into 10, 5 times. It goes into 6 3 times. It goes into 14 7. So I have to take this 2 because it is able to go into the numbers here. So I think that is done. We can get any number that can go into all the numbers here again. So let me take 5. 5 goes into 5 1, goes into 3. That's not possible. Right? The same 3 goes into 7 7. So the next one is going to be 3, goes into 1 1, goes into 3 1, goes into 7, the same 7. And I've got to take 7 to complete it. 7 goes into 1 1 1 1. So therefore the highest common factor is equal to the product of the number that we selected here. So that's going to be 2 times 2. That is going to be 4 or 2 squared. So that is the highest common factor of 20, 12 and 28. Let's take the last one. Let's find the highest common factor of 48, 60, 96. So let me get my table. So I have my table ready. So you have 48 here, you have 60, and that of 96. So let's use 3 here. 3 goes into 48, that's going to be 16. Goes into 60, that's going to be 20. And here 96, we have 32. So let's simplify. But before we simplify, we should know that 3 was able to go into all the numbers, so you have to highlight it. Let me take 2. 2 goes into 16, 8, it goes into 20, we have 10, goes into 32, that's going to be 16. So we have to take these 2. Let's take the next one. We can still take 2. 2 goes into 8, that's going to be 4. It goes into 10 5 times. It goes into 16, 8. So you have to take these 2. All right, so we have 4 5 and 8. So let's take 2 once again. 2 goes into 4, 2 times. It goes into 5. That's not possible. Right, the same 5 goes into 8, 4 times. So that means that we are not going to get any number that will go into all the numbers again. So this is actually going to be our highest common factor, 3 by 2 by 2. But let's continue to the last point. So we have 2 once again. 2 goes into 2 1, goes into 5. That's not possible. And 2 goes into 4 2. Let me take 5. 5 goes into 1 1, goes into 5 1, goes into 2. We have the same 2. So the last one is going to be 2, goes into 1 1 1, and out of 1. So the highest common factor is equal to 3 by 2 by 2. So that's the same as 3 by 2 exponent 2. So that's going to be 12. So the highest common factor is 12.